All right, perfect. We are up and live and streaming on YouTube. So why don't we go ahead and get going? Awesome. Thanks everybody for joining us. My name is Rebecca Warren. I'm from the Stackhawk team, and I'm really excited for today's session. With me from the Stackhawk side is Scott Gerlach, who is our Chief Security Officer, and we're also partnered up with the team from R2C. So we have Clint Gibler, who is their Head of Security, and Pablo Estrada, who is their VP of Marketing. So I'm going to go ahead and pass it over to Scott and Clint, who are going to be leading today's session, but we want this to be super interactive. Pablo and I will be here in the chat to help field questions. So if anything comes up as we're going along, drop those in. We'll try to get you an answer as soon as we possibly can. But it should be great. We're lucky to have Scott and Clint leading this one. So take it away, Scott and Clint.
Awesome. Thanks, Rebecca. Welcome, everybody. We're not talking about high school stuff anymore. We might come back to that at the end. If you missed the beginning, there was lots of high school confessionals. Today, we're talking about application security, testing, why and when, and some of the interesting things that are changing in some of the tooling around application security. As Rebecca mentioned, if you have questions or a comment or we lose you, hopefully we won't lose anybody, but if we do, send us a message in the chat. We'll try to get to those questions or comments as we go through it. We definitely have time for questions and answers at the end. We also have a cool demo planned for you, so we'll get to that as well. But first, Clint and I are going to kind of level set a little bit, and we're talking about application security testing and some of the types of tooling. We're going to talk about that. Obviously, the Stackhawk team and the R2C team have a preference on what kind of tools we're going to talk about today. So today we're talking about SAST and DAST. There's other great tools out there as well, but those are the ones we're focused on in our webinar. And we're going to also talk about how those two things can be very complementary and show you that in a cool demo. And then I've also got publicly available demo stuff that we can send out to everybody. So if you want to play around with fork, change, test, etc., you definitely can. And then we'll clean out or end out with some quick advice on rolling out SAST and DAST, and then get to our Q&A. But first, cool graphs and charts time. The very first thing we want to talk about here is just teams are changing how they approach application security, and there's really good reasons for doing that. And one of them is cost. So this chart is really about how much relative cost it is to fix application security bugs as the life cycle of an application goes on. So this chart is kind of a relative chart, and it's basically once something gets released to production and is out there in the wild, and you start discovering application security bugs or bugs, just general bugs, the cost to fix those things is about 28x as it would be to deal with that when you're doing requirements in architecture and design, and then maybe 25 times more than it is while you're doing code. So the interesting thing here is, how do we get, again, this is that whole shift left thing, how do we get all that testing to happen while we're writing code or while we're testing applications into the hands of engineering so that they can understand and fix those things early? And a lot of people are kind of getting to this point where, they've determined that they can't hire 11 billion different AppSec people to work at their company to monitor every line of code. And they need to figure out, AppSec teams need to figure out how to scale this efficiently. So we're talking to a lot of different people out there in the industry that are thinking about this, right? I can't scale me, I can't scale my team as fast as the engineering team can go. So I need to find tooling that will help me do this. Clint, I know you guys are talking to different teams out there. Are you hearing similar sentiment or different sentiment, or what are you guys hearing as well?
Yeah, definitely. I've heard that from a number of companies as well. I think the sort of like an interesting shift, at least I see in security teams, is going from sort of this external security team that's trying to sort of foist security onto developers, but rather like, okay, how do we become like a security engineering team? Like, how do we build like secure by default libraries or secure by default services that developers can leverage, as well as just really become partners with them and have a customer-centric approach. So rather being, like you shall not pass, you can't do this, developers, but rather like, okay, how can we enable you developers to do your job better, faster, easier than you were before? And also secure, by the way. So totally agree.
Yeah, awesome. And so many of you who are attending this webinar may be thinking like, hey, how can we do this in a sane fashion? And fortunately, we built a slide for that to help you understand. No, I don't know. The answer is obviously security tools that are built for developers. So as Clint was saying, it's really hard to gatekeep. And when you start doing gatekeeping and point in time decision making, and you have to check in with the security team, you start getting a lot of pushback because it's hard to self-serve. It's hard to solve your own problem. It's hard to continue going in your development workflow when you have to go talk to the security team or go, hey, can you guys run this thing and then send me the Jira ticket on what you found afterwards? That's not a good experience. And there's lots and more tools being built for developers. So application security tooling that is being built for developers. And the security testing methodology and idea and tooling and all that stuff isn't new, as we talk about here, but the developer friendly versions of them are, and they're becoming more and more prevalent in the market. So the ability to easily run a tool, quickly understand its output, works in development flow. So can work in CI/CD, can work while you're writing code is super important, because if it's a black box, it tends to get ignored or forgotten about. And if you can't figure out how it works or figure out how to work it, if you can't understand the output, that is also very difficult. So when you start looking at these tools that are tailored towards developer workflow and developer output, they scale more efficiently because we're giving this information back to developers very quickly so that they can find, address, fix while they're working in code. So staying in context of what they're actually working on. If they introduce a new problem, being aware of it, and then being able to fix it quickly. Any other points there, Clint?
Nope, not for now.
Cool. So how can we do this is a really good question. And both of our companies are leveraging open source tools. Clint, I think you're leading this one.
Yeah, so I think an interesting question is, how does open source fit into this? So as Scott was saying, so R2C is building SendGrep, an open source tool. Stackhawk leverages OWASP Zap, also an open source tool. And from what I've seen, I think open source is great for getting developers involved in sort of getting a feel of a buy-in in your security program. And again, sort of working within their development workflow. So GitHub, GitLab, and things like that in their context. And I think what's great about open source tools is they tend to be very fast, very extensible. So they're not just this black box. You can understand how they work, how can they be tuned for you, and also reliable because they're sort of community supported as well. Yeah, so just getting into it a bit more detail, like I think just for security professionals or developers, when you have this tool that you either are choosing to use or have to use, and you don't understand its internals and how it works, and you can't change it, and you're just sort of like, I have to use this, it's just not great. But if you're like, oh, like, why is it doing this thing this way? It's bothering me. Oh, you can actually look and see and potentially extend or change or fix it if you'd like to. So I think this extensibility and customizability really builds sort of a feeling of ownership. And also, in some respects, a feeling of community where you're like, hey, it doesn't do this thing that I want it to, but I can actually contribute back that functionality. And you have this sort of warm and fuzzy feeling because we're all building this thing together and building a better tool for everyone. But, open source can have some flaws or cons as well. So many times developers or security professionals building an open source tool are like, hey, this works on my machine. It's fine enough for me. And they don't necessarily put in the extra work to smooth over the sort of user experience, their sharp edges. So, workflows can be not great sometimes. Oftentimes there's This is like a side project from some open source developers, so there may not be a dedicated support services component, which may be important to you if you're relying on this for your company. Oftentimes, open source tools are great for like running one-off just you on your laptop, but if you're trying to scale across hundreds or thousands of repos, for example, this can be challenging. And depending on the tool, the learning curve can be steep. So, there's some great strengths here, but also some cons if you're, strictly doing just open source without some sort of community or company that's really trying to push this forward. But yeah, let's go to the next slide. So that's some like big picture ideas and just sort of level setting, but let's dig into the types of security tooling we're going to be talking about today in a bit more detail. So first, static testing or static analysis is examining source code without running it. So you're just sort of reasoning about the program as sort of source code on disk. And Scott, dynamic testing?
Yes, totally. So dynamic testing is a little bit different because it's actually testing running code. So as you compile that code or expose its service as a HTTP endpoint or some other kind of running application, dynamic testing is looking at that running application and testing how it deals with user input and user output and lots of different things that it's presenting. So in a HTTP application, security headers that it has or doesn't have, and how you're dealing with cookies and session and all kinds of good stuff that oftentimes can't be seen when you're doing static testing.
Cool. Well, yeah, let's go to the next slide. And so that's like big picture. Let's go into a little bit more detail. So in general, this is how static analysis tools work. You have some source code. You parse it into an intermediate representation. So you can think of that like an abstract syntax tree or AST, or other tools use more like a graph approach. You then combine that intermediate representation with some security checks, basically like, hey, I know that, if user input comes in from here and goes to this, say, unparameterized SQL query, I know that that's bad. So given sort of a structured representation of the code and security domain knowledge, then there's like a core engine or pattern matcher that sort of applies those together. And then the output of that is security bugs. And what's interesting about this approach is this overall architecture is actually not so different than what like compilers or interpreters do. So they're also taking source code, parsing it into an intermediate representation, and they may be focused more on sort of correctness or robustness or things like that. But static analysis tools leverage some of the same approaches, but more for finding security bugs, at least in the case we're talking about today. So what are some great parts about static analysis? So you get high coverage, right? So you can scan for vulnerabilities across, all, whatever millions of lines of code in scope. So you don't necessarily have to exercise all of that functionality to be able to reason about if there's a vulnerability there. So for example, you can imagine a web app or a desktop application that's like, the bug is like, well, you have to like fill out this field, click here, go here, and like it's like 50 steps deep. And being able to have a script automatically reason through deep program state is possible, but can be quite challenging in practice. Static analysis can also be very fast. So you're just reasoning about the source code. You don't necessarily need to build, spin up a live instance, make thousands of HTTP requests. You can just sort of analyze it all from the source code directly. And the results can be more targeted and actionable in terms of, you can say, hey, on this line of code, I think this security vulnerability is occurring, and here's where you should fix it, developer. So some trade-offs, some cons here. Static analysis can have false positives in that there may be specific program flows or issues that you think can happen, but actually can't in practice because of some sort of global state or other parts of the code that the tool doesn't necessarily know about. Static analysis is language specific. So if you want to, say, scan your Django web application, the tool that you're using needs to be able to parse and reason about Python. So you do need like language specific support. And another thing is it can be challenging to find bugs across repos. So let's say, for example, there's a vulnerability that like, this microservice talks to this one, talks to this one, talks to this one. And unless you're sort of analyzing the code in a way that can reason across all of these things, that can be difficult for static analysis, where A dynamic analysis perhaps like doesn't care about how many repos are involved or if there's middleware or proxies. It just observes the behavior and like, okay, this is what's happening. So yeah, next slide. Okay, so what's new? I think this sort of next generation of static analysis tools emphasize being very customizable. So previously tools came with many out-of-the-box checks, but if you have issues specific to your company, like we have this own customized web framework internally, or this is a business logic flaw for us. If this API gets called before this other API, or you don't do this check, like that's a bug for us. Typically, prior tools, you can customize them a little bit, but it tends to be very hard and take a lot of time. That's less so now, at least with what we've been investing in. Many companies we notice are focusing on high signal results. So they're okay missing some things if the things the tool reports are very high signal. So sort of like, tell me when you're very confident, otherwise don't bother me, is a trade-off I see many companies choosing to make. And then again, something we've been talking about a lot, being very dev friendly. So how can we meet developers where they work in the systems and tools they're used to, rather than having a separate dashboard or interrupting their workflow? So here, for example, we have a screenshot of SendGrep giving a PR comment. So it's like, hey, I just wrote some code, I pushed it in, and while their developer colleagues are giving them maybe stylistic or other feedback, they could get security feedback immediately as well. Cool. Yeah, to you, Scott.
Awesome. Thanks, Clint. I think the other thing that's awesome about some of this new tooling is the new tooling for SAST can also scan where the code lives. So if whether that's GitHub or GitLab or Azure DevOps repository or whatever, instead of like zipping that code up and sending it off to a different tool, where that code lives is where it can be checked and tested, which I think is also super cool and removes an extra unnecessary step. Awesome. So I'm talking about DAST a little bit. For those that don't know, here's a really genericized version of what DAST does, how it does it, and things it finds. So as I mentioned before, in the case of an HTTP application, so a REST API or some kind of HTTP application, GraphQL, SOAP API, etc., things that present themselves on HTTP protocols, DAST scanner, like the Stackhawk one, actually sends requests and inspects responses from the app. So it's trying to do things like find SQL injection and OS command injection, cross-site scripting problems, but it's also looking for stuff like, how are you setting cookie settings? So are you setting max lifetime cookies, which are HTTP that have your session token in them? What kind of content security policy problems exist in your application? Can people iframe your application and therefore then potentially clickjack your application? Lots of different things that kind of it needs to present itself to be able to find. And then there's a handful of other web application security issues that go along with this. If you're thinking about the OWASP top 10 in any of its flavors, both of these tools kind of do that, but they do it in a different way. So thinking about, how do you combine these two things to find the most coverage across the OWASP top 10 is a really interesting thing to kind of think about. Let's see. We got a question, Clint. We're going to hit this question. How accurate is your SAST tools? One of the issue with SAST is high false positive rate. What is done to diminish this issue?
Yeah, thanks. That's a great question. So a couple of things. So one is, as we are vetting new rules we write, we actually have sort of hundreds to thousands of test repos from GitHub that we run every rule on, and we manually triage the results to see, is this rule effective in practice? Is it flagging things that it shouldn't have? And if so, we update the rule. So there's sort of like this iterative feedback approach. Also, I think SendGrep philosophically is different than other tools. So traditional tools focus on like, how do we do interprocedural data flow analysis across many files? So how do we track user input from here to here to here to here to here? And I actually interned at Fortify when I was a grad student. And as a consultant, I helped many companies set up other tools like Fortify checkmarks and other. And in practice, what I saw from many companies is that the cases that were false positives tended to be like long call chains. So doing very complex interprocedural data flow analysis tends to be both slow and imprecise. So currently SemGrep focuses on being as fast and intuitive as possible. So we actually focus more on intra-file analysis. So there's trade-offs there, right? So we can be very fast. We don't need a buildable environment, which many tools do. So we can be scanning in like minutes instead of hours or days. But on the other hand, we're not necessarily like trying to find everything, but we are very like quick and high signal because we can say, hey, within this file or within this function, we are very confident this is an issue. And we also focus more on, I think, modern security in terms of many companies. If you look at sort of the recent Google SRE book or like Facebook, Netflix, Dropbox, like all these companies, they're thinking like, instead of how do we focus on finding vulnerabilities, how do we create secure by default libraries and make sure everyone uses them? So it flips the security problem on its head. We're like, how do I detect when people are not doing the thing that I know is secure? And that's sort of what we're optimizing for. Like, how do we ensure that you're doing the right thing that kills classes of vulnerabilities rather than finding a one-off bug? So for example, in React, like dangerously set entering HTML, this is dangerous, you should probably not do that. And there's other classes of this in every language and framework. So I think that was a lot of words. In short, we're focusing on how do we do sort of fast localized analysis because that tends to be higher signal, and also trying to encourage developers to embrace secure by default libraries and just secure by default paradigms so that you don't have to do sort of the more complex, slow, and also less high signal approach. But yeah, hope that helps. And thank you for the question.
Yeah, awesome question. Jumping back into DAST stuff. So awesome parts of DAST. So Clint was talking about one of the drawbacks of SAST is it has to have this language dependency thing, has to understand what the language is and how it works to be able to test it. DAST doesn't care about that. DAST cares if it can check the running app and interact with it. And that's really it. So if your engineering team is like, hey, I want to use Rust, or this happened to me at my last job, hey, we want to use Go. And you're like, that's super new. There's no tools out there. DAST doesn't care. So that's why I kind of like DAST. It kind of understands the context of how the application works a little bit better. So it's testing that running application and looking at data flow as the application is handling it, which is actually pretty awesome. And I think DAST tends to have lower false positive rates because if DAST finds a security bug in the application, it almost certainly exists. That doesn't mean it's false positive proof. However, usually there's good tests to be able to recreate that stuff and actually try to exploit the same app or the same application in a way that the scanner did. So you can do some verification and like proof of concept stuff. And that's pretty cool. The sometimes less awesome parts of DAST historically has been really hard to automate. So a lot of legacy DAST tooling is really, really complicated. If you've seen any of my other talks, I usually put up this like old 1950s nuclear reactor control panel with lots of buttons and switches. And I feel like that's what a lot of DAST tools used to look like. And then the other part here is because DAST is not aware of source code, it also can't go, here's where the problem is, you should fix this line. And so that can sometimes be tough in a legacy application or in a tool that, or an application that no one has worked on, or people are coming into new and they don't understand how it works necessarily. But the cool part of that is if you can get that into a workflow of development where they're iterating on code and we're finding new issues in the application that were probably introduced in that code, it makes the where is this much, much easier. Let's talk about what's different about Stackhawk. I like what Rebecca put in here, making the less awesome parts more awesome, because that's how we roll. We want to be able to automate this stuff in CI/CD, and the important part that I'm going to say here is in, not with. So we believe that being able to run the scanner in CI/CD, not make CI/CD go, hey, run a scan against this publicly available endpoint. is super important, because at that point, you don't have to publish does this thing have security bugs to the open internet, which could end up bad. Hopefully it doesn't, but it could. API coverage, understanding more and more about how REST APIs work, GraphQL APIs work, and SOAP APIs work, and being able to test them very thoroughly is super important to us. Developer-friendly features like, how do I recreate this attack so that I can get into debug mode and start stepping through code and see where I possibly made a mistake, and don't have to ask somebody, hey, cool, you reported a cross-site scripting, how would I even make that work? Back and forth. And then making the configuration really simple and the deployment really simple is a core piece of how we do that. And we do that through a YAML file and Docker. So pretty simple technologies out there. That's not a lot of UI button and clicking, but much, much easier. Let's see. Lawrence asked me a question about how do you deal with discovery challenges like directory brute force and spidering? Do you support forced browsing with things like Selenium or sitemap inputs? So the answer to this is really, really long. It depends on what technology you're using. So if it's a regular HTML app, the underlying Zap technology that we use has a great HTML spider. If it's a single page app, there's also an Ajax spider in there, but we highly believe in testing APIs directly. So we support REST API specs to be able to confidently and completely describe a REST API and test the whole API. We also use GraphQL introspection, and SOAP has the WSDL. So we ingest all of those different kinds of things to be able to test the application itself very, very thoroughly, and kind of avoid that whole, can it crawl all of my single page app to find all of the API endpoints? Just test the API itself. There are really good things to find in single page apps like cookies and DOM XSS and some of that stuff, but really the interaction with the API is super important. It's a good question, Lawrence. I think this also answered the other question about DAST. I'm yet to find a tool which can get good coverage. Have you seen this? I think I just talked about that a little bit. The other question there is, another DAST challenge is MFA hurdle, which is common in all enterprise apps. What's your view on this? And have you found a tool which helps take care of it? Yes, this is a really common problem. And the answer is not automate the MFA. We're trying to test things in production that have anti-automation features enabled on them, rate limiting, MFA, et cetera, et cetera, et cetera. And usually in a lower environment, they don't require MFA to do testing. So one, if you can test earlier where those requirements don't exist, that's better. Two, if you can write a script against an Auth0 endpoint that has MFA or some other endpoint that you can already grab a token out of or some kind of credential, we support injecting that into the scan in various different ways. So it's not about can the scanner go do the authentication piece, it's can the scanner take the credential that you've provided for authorization and provide it in its scan, which is mostly how we do that. And then last one here, sounded like you have internal teams verifying what's found with the automated scanner. Is this what's happening SAST and DAST? So I think, Clint, you talked about that a little bit with SAST, verifying findings and all those good things.
Yeah, so quickly, when we are writing tools or when we are writing new SEMGRUP rules to provide new coverage for different vulnerability classes or languages or technologies, we do vet the results on many open source projects. But in terms of are we triaging the results of our customers, that may be sort of like a managed service thing we do at some point. And we do like one-off help people if they have specific questions, but like day by day, we're not reviewing all results from all of our customers unless they want help.
Yeah, so same on the DAST side. We're not necessarily looking at every single finding throughout the platform, but when customers do mark stuff as false positive and or ask us about them, not only do we help explain it, but we also send that feedback back to the open source project to say, hey, this could be improved, or I just finished doing one of these recently, actually writing a new test or fixing a test so that it is more true positive and less false positive prone. So lots of feedback, I think, on both sides here to open source communities and customers of the platform. We're going to rip through this next part because it gets us into the demo, but we're talking about SAST and DAST together and why these are super powerful tools if they're used in an interesting way or a smart way that can help you kind of focus on what to fix. And if you end up with same finding in multiple different tools, that is actually a really good place to go. Hey, if this thing pops in both of these tools, that's probably the thing that we should fix because it's discoverable and exploitable, and it points at a line of code that we can probably go address. So there's much higher confidence in both of those things when both tools find them. One of the challenges here is across different tool sets, languages and descriptions are not always similar. And some of the tooling like Serif, which is a standardized output for static analysis, can unintentionally create high cognitive load. And we're going to see some of that a little bit in our demo. But I think there's really good stuff to talk about through this demo. And I will jump into that right now. So I've got out here on GitHub, we've got a Django project that we've been working on. So this is a vulnerable Django application. It's regular Python Django. It's actually the Django tutorial on how to create a polling app. So you can ask questions, people can vote, lots of good stuff. It is that, but it has problems in it. And what we did was we set up GitHub workflows to work with this. We're definitely going to have question and answer time at the end. So if anybody gets lost here or needs a link, I think Rebecca can drop the link into the chat. We'll definitely work on that a little bit. And the resolution has been increased. So hopefully that is better for everyone. Thank you for asking about that because I always forget. But what we did here was we set up GitHub workflows to make both of these tools work in this repository on code commits and on pull requests. And so what I'm going to show you is how we set that up. And they're both really, really simple because we both have good GitHub actions. So the top part here is how to set up the Stackhawk DAST action. You can see that I've got a configuration file that we're actually stacking here. I'll jump into that a little bit later. But what we're doing here is spinning up the Django application in a Docker container, spinning up the HawkScan scanner container in CI/CD. Those two things are talking to each other, testing, and then they tear themselves down. Totally ephemeral environment here. Pretty easy to set up, especially when you have a Dockerized container. And then the second action that's happening here is we're running a semgrep scan against the source code here. So again, the semgrep action from GitHub. And both of these things are trying to output Serif information. So we'll look at that a little bit. But that is the basics of what this GitHub action looks like. So you can see we're testing the running application and we're testing the source code, DAST and SAST here. And when we go up to actions, we can see that these actions have been run recently. Clint and I have been making some updates to this application, trying to get it into good shape. And we still have some work to do, but you can see that the Stackhawk scanner ran its scan and had a bunch of output about things that it found, and particularly interesting things I've already triaged. So I've already done something with this cross-site scripting, but I still have these SQL injection guys sitting out here that we need to do something with at some point. Let's see what we found in this semgrep scan as well. Uh-oh, I looked at the wrong one, didn't I? The demo gods. I think it was this guy. Yes. So you can see the semgrep scan failed here as well. Clint and I have been working on this to try to make this awesome, but the demo gods, we tempted. Anyway, so you can also see here that semgrep found a SQL injection as well. So right around this line in this file, we've got some SQL injection interestingness happening here. Both tools are now reporting a SQL injection. So what's interesting is in this SAST activity, we can go, hey, look at this line. It doesn't look safe. And I would probably agree with that. It just kind of takes user input and jams it right into a SQL statement. Probably not good. The interesting part here is like, how could I recreate this kind of attack? And that's where using both of these tools actually comes in really handy. So now I know what file and what line I'm supposed to be looking at, I think. And in this Stackhawk scan, I also have this SQL injection. So we can actually go look at that in the platform, which actually looks like this guy. So both of these have SQL injection. Both of them have a potential attack or potential place to fix them. And the cool thing is from the Stackhawk platform, now I've got a curl command I can replay at this application, set my breakpoint or my debug point inside of that views file, start stepping through and looking at how this code flow is happening and be able to recreate this request and debug it a little bit. Clint, I know you wanted to share your screen and show some stuff that I couldn't get to work in my demo. So I'm going to stop sharing. If you could do the sharing and show everybody how that's supposed to work with PR comments.
Yeah, definitely. Thank you. Yeah, for some reason we attempted the demo god some permissions issue, but yep. So this is actually me forking the exact same repo that Scott ran, and for me, I was able to get these PR comments. So basically the same thing you saw in sort of the drilling down into the action view, but here, right here on the pull request itself, so that the developer in their existing workflow can easily see the issue and also like click for more information or things like that. And also maybe adjust their policy, or they can say, how do I suppress this? You can like add a comment in your code, or sort of server side in our app, you can do that as well. If you think something is a false positive, you can also basically anything you might want to do with this issue, you can do it sort of quickly right here from your existing tooling and workflow. But yeah, back to you, Scott.
Awesome. Ooh, I think you have to end your screen share.
No, Zoom. How though? No. Sorry, I'm not seeing the buttons.
Yet another demo god failure.
Okay.
The little Zoom bar is just going to be floating around somewhere.
Yeah, it is not at all. It's on my other screen. Okay, sorry, I see it. Cool.
Someday maybe we'll have just the problems with Zoom webinar. Okay. The other thing that I wanted to show everyone was both of these tools have the ability to output serif information. So you can see we actually have alerts out here in the security tab. So both tools have kicked out a serif file. Both tools have put things into the code scanning alerts. And now we can see that we've got the same SQL injection information from SemGrep in here, and that Stackhawk also had some findings that meet or exceed failure threshold. And I'll show you how that actually works in just a little bit. But what it says is we have some high results in here that met the failure threshold. So you can set Stackhawk failure threshold to be high if that means that if it finds a high severity finding that has not been triaged, it will also exit in a non-zero fashion and break the build as well. So as you get to kind of a baseline status and use both of these tools to kind of go, okay, I understand what's going on here, you could then move that into a break build kind of a policy that says that is basically, hey, you have to at least triage these things and like make a decision on them before your build can pass. And once you do that, fixing is obviously better, but triaging is a really good step as well. Then the build can actually move along. So it's easy to be able to go, hey, I'm trying to bring your attention to this thing. I need you to take some kind of action, and you can self-serve and you can get on with the business of creating applications and value. So I know this is super confusing. I'm going to leave this up because I'm sure there's lots of great questions about what we did here. I have now lost my Zoom bar. Wait, nope, there it is. Yay, Zoom. So happy to answer any questions that anybody might have about this, or dive into the action a little bit more, or anything anyone wants to know about, or talk about other topics, questions about just SAST and DAST in general. Hit us with those questions. Clint, was there anything else that I missed that you wanted to talk about here?
We hit most of it. I guess one quick thing is, SemGrep, the CLI tool, and all the rules are open source. Use them however you want. And what we found is that people who wanted to run SemGrep at scale across hundreds or thousands of repos wanted some sort of like metrics or dashboards, or basically like, how do you tie everything together nicely? So we have like a SemGrep SaaS app as well that lets you say like, hey, I want to run these rules on these repos. You might say like, for my production apps, I have a very high security bar, but for internal apps, I want to make that a little bit lower so people can iterate more quickly. So we make that easy. And you can also say, these security checks, I just want to sort of audit. So if you're trying to roll out some new rules, you can say like, maybe send the security team a Slack message when you find something like this, but don't bother developers. Whereas other things, you could say, I have very high confidence about this. If I find this, please block the build. So we have very fine grained, like for each specific security check or for each repo, you can say, do I notify only, block the build, or whatever. So we're not going to show that today, but yeah, you can also use that for free today if you would like.
Yeah, tons of customization and configurability. As I was trying to set this demo up, lots of interesting stuff. Got a couple of questions coming in. If I have an internal code base or internal site, how would that be scanned? So I'll talk about DAST. Obviously, Clint, you can talk about SaaS side of this. So the Stackhawk scanner is just a Docker container. If you can run Docker inside your network, you can test anything that is not publicly available or lives behind some kind of a WAF or in a VPN or whatever. And it actually makes it faster. So if you can get the scanner to be next to the application, you lessen the speed of light problem in request response round trip time. So anytime you can run Docker inside your network or wherever those apps might live, you can test them with a DAST tool like Stackhawk. Clint, same question for SAST.
Yeah, so basically, wherever your source code lives or whatever CI/CD processes you're using, SemGrep can easily run there. So if you're on GitHub using GitHub Actions, you can do that very easily. If you're using GitLab, we can do GitLab runners. If Travis CI, Circle CI, Jenkins, basically whatever CI/CD tooling your developers are already using, SemGrep can easily fit into there with, we have example config files that show like how to set it up in whatever system you're using. And usually it's like 10 or 15 lines. So yeah, GitHub, on-prem, really just whatever you're using, SemGrep can fit there.
There's another one in here for you, Clint. Using SemGrep, is it possible to discover role-based authorization security issues?
Yeah, that's I really like that question. So one thing that's interesting is pretty much every company does access control differently. So no out-of-the-box security checks are generally going to find that. But I think this is actually a strength of SemGrep, because when you're writing a SemGrep rule, it's basically just the source code you're targeting with a few helpful abstractions. So you don't need to spend weeks learning a separate domain-specific language to write a SemGrep rule. Basically, if you're writing a check for Python, it's basically going to look like Python code, and same with Java and so forth. So basically, if you know what authorization looks like for your company, maybe there's like an annotation on a controller method or a specific API call that's called. In probably about 5 lines of SemGrep, you can find issues like that. And we actually have some demo example rules that I can show you in a second. I'll let maybe Scott answer the next question as I bring it up. But short answer is no tool is going to find access control issues out of the box, because every code base looks different. However, in SemGrep, it's actually very easy to customize it so it's specific to your company. And I'll show you why or how in like 2 seconds.
Yeah, I was actually going to answer a little bit about the same question, because I echo your sentiment that no two companies do authorization the same way. And oftentimes this shows like there is a OWASP API top 10 called BOLA, Broken Object Level Authorization, that describes what this particular issue is. And it is often referred to as tendency filtering by people who write code. So making sure customer A can't see customer B's data, it is very, very distinct per company, per application, how that works. And so the ability to customize a test and be flexible about how it works is super important. This is actually something we're working on, adding the ability to add to Stackhawk tests in the next quarter or 2 quarters, because lots of people have been asking for exactly that. So good examples, again, on how to do this and how to extend the scanner on the Stackhawk side, as well as on the SemGrep side, are really important here. So I just wanted to kick that in there as well. I think you're working on a screen share maybe, so I'll stop screen sharing while I answer this other one. How do you leverage automated functional tests in Zap or in Stackhawk? Zap allows it. So that's a really good question. And what it means is, can you proxy functional tests through Stackhawk the way that Zap allows? And the short answer is no, because it is very kind of difficult to set up that whole proxy environment inside of CI/CD. And when you do that, you can't also necessarily run active tests, which are really the bread and butter of a DAST scanner when it sends input and receives output itself from the application. So today we don't do that, but that doesn't mean we won't in the future.
Cool. So here's a quick example. So let's say we have a Spring application and there's a sort of specific header we care about that's doing the authorization. Just to back up for a second, this is the SemGrep editor or playground. So you can actually run SemGrep in your browser without installing anything, which is pretty cool. So here, this is up here is like the SemGrep pattern you want to find. Like this is the code that I think is interesting. Then you can copy some of your source code or just write some example code here. And basically SemGrep is going to take the pattern, apply it to the code, and then tell you like, did we match? And if so, where? So here, basically what we're saying is like, I want to find every function. SemGrep has the idea of like, basically to abstract away, I don't know what this thing is. Like this function could be anything. So I'm not going to go into too much details because there's probably other questions and stuff to go through. But basically, all you have to do is say like, okay, find every function that has a request mapping annotation, and we can say and is not. Then basically we can say, what is the thing that we don't want to find? Anything with this annotation. So basically find all the routes, filter out the routes that have this authorization annotation. Oops, no, this is supposed to be this, I think. But yeah, sorry, doing it live here. But basically the idea is find all of, here we go. Yeah, so this route has the authorized annotation, so we don't find it. This one does not, so this is an unauthenticated route. So we want to match this. And this other has like a, this is just a user permission, not an admin, but it still has this annotation. So yeah, basically in about 5 lines of code in like 2 minutes, we were able to find all unauthenticated routes using SemGrep. And yeah, I can give you more examples after this, but this is sort of a quick example.
That's a good one. I like it. Another question somebody asked, is it possible to pull results from both scans out of GitHub for comparison and triaging together? Today, it's not wicked easy. However, it is possible. Stackhawk supports a webhook. And I think you could also probably webhook out the SemGrep results from either the platform. I'm not sure if the platform has it today, but I think you could webhook it out from GitHub itself to put all those results in one place to be able to kind of hopefully correlate them there. I think the more interesting thing is to be able to alert while they're in the PR or in GitHub in the flow that's happening. And as we continue working together, we'll make some of this correlation cognitive load a little bit better. We're actually working with GitHub to figure out how to redefine that serif format so that it makes more sense. It doesn't Serif is all about static code analysis, and it doesn't lend itself well for dynamic analysis information. So getting some more of that information to make the cognitive load less. Obviously, it's totally doable today if you go, hey, I found SQL injection here and I found SQL injection here. Cool, let's go work on SQL injection. It could be easier. I'm not saying it couldn't, but alerting and giving developer feedback in the workflow area that they live in, I think is super important. So doing stuff like giving feedback on PRs or breaking a build action with some kind of actionable information, I think is important. And being able to triage that all together in one tool, I know it can be better. How's that?
And two quick things. SimGrep SaaS app has a REST API, so anything SimGrep finds, you can easily extract via REST. And there's also a webhook as well. So like as SimGrep is finding things, if you have an external dashboard or system that you just want to see results as they come in, you can set up a webhook URL that points to whatever you want. So yeah, you can get the data out pretty easy.
Look at me. I didn't even misspeak about the SimGrep platform. I'm pretty sure. I was pretty sure I saw a webhook thing in there.
Yep.
Awesome. I think we got just a couple more slides, kind of wrap up. Clint, this one's all you.
Sure, thanks, Scott. So based on working with a number of companies, there's certain patterns that we've observed being pretty effective at just rolling out, whether it's a SAST tool or a DAST tool. So for example, generally you want to start with like an initial POC, where maybe you're choosing one specific repo rather than rolling it out to everywhere all at once. So, maybe like, what is the most common tech stack in your company, or what's an important one? Okay, cool, we'll start there. Is this working how we expect? Okay, then maybe branch off, because many environments are very polyglot. And then specifically with regards to like what to do with results, oftentimes we find AppSec engineers tend to get better buy-in from developers if there's like a sort of a careful and planned rollout. So first you might say, okay, let's integrate the security tool, but maybe I'm just going to send the results only to the security team in sort of a notify only mode. And then after a week or two, you're looking at what results are firing and what's not. And you're like, okay, like I have high confidence in these results. It's not going to spam developers, it's going to be fine. So then maybe gradually you start notifying developers with some subset of results. Like these are high signal things that I know that if it finds, developers should care about. And then gradually after that, maybe you start blocking builds for the subset of things that you think are very high confidence. So basically, start small, build from there, and maybe initially send results to the security team, then gradually notify developers about it, then eventually maybe start blocking builds. But depends on the company. So some high assurance companies, maybe like banks or something, you want to be super confident and you might block builds more aggressively, where if you're a small startup, engineering velocity is more important. So maybe you focus more on notify rather than blocking. Another effective approach can be focusing on specific vulnerability classes. So maybe you have systemic cross-site scripting or SQL injection or something else. So maybe you focus on that and not try to boil the ocean and solve every class all at once. I think there's also a nice sort of just-in-time education component to this, where rather than having once a year security education that people promptly forget in a few weeks because it's not always relevant and brought up, you can instead say like, hey, this type of issue just happened. Maybe let's do a brown bag and teach everyone about it. And ideally, the tools you're using are giving good education that's actionable. What is this? Why do we care? How should I fix it? And things like that. And again, something I think we talked about throughout this discussion, I think using the existing CI/CD tools and platforms and websites that developers are already using, so that security is just another one of the linters they're probably already running, I think is the most effective way to get developer buy-in, rather than like, oh, you have to manually run this separate tool and go to the separate dashboard and view results somewhere else. This is, I think, a bad experience for everyone. So the more we can make security seamless, intuitive, and just another part of the development process, I think the better. So,
yeah, I'll echo what Clint said there. When I talk to application security teams, or they're my application security team, I usually tell them, hey, let's go find an engineering team and let's go partner with them. Like go to their daily stand-ups, go to their scrums, figure out what problems they're trying to solve and how you can help them as a security professional. And this kind of takes the same thing. Like if you want to change how your AppSec program works, or you're trying to start an AppSec program, start small and iterate. Like you can't just big bang any of this stuff. It's not going to go well. However, if you partner with an engineering team and help them with the problems they're trying to solve and give them more information so they can build higher quality software, they will see you as a partner and a champion, and they'll even probably talk nice about you with their friends. And then you can expand that stuff start iterating throughout the organization in priority matrix. So most important application, second most important application, get to that least important application last. Make sure everyone's getting serviced the right way on those high risk, high importance applications and engineering teams. So webinar recap. What did we talk about today? If you weren't here earlier, obviously the high school confessional was really important at the very beginning. If you missed it, it's part of the recording. You'll get a link. Super informative. However, the really important stuff that we talked about was how SAST and DAST tools are shifting left and helping enable developers to understand and fix security issues with the help of open source software. The value of using SAST and DAST together. There's often this like battle in the application security sphere of which thing is the best. They both have pluses and minuses, and when you use them together, they can be very, very powerful. And then once again, start small with your rollout, grow from there. Figure out how it works and how it doesn't work, and get feedback from your engineers. As those teams are consuming some of this information and they go, this is terrible, figure out how to make it not terrible. Help them create better software. Clint, anything else I missed?
Nope, that sounds great. And yeah, thank you so much, everyone, for coming.
Yes, thank you, everyone, for coming. If you missed anything or you have questions, feel free to hit up Rebecca. She'll answer all the questions you have or forward them to the right person to be able to answer the question. I think the webinar recording is going to be coming out shortly. I think that's it, right? Rebecca, what did I forget?
No, that's everything. We were live streaming this on YouTube, so we'll share the YouTube link with everyone. So it's super easy to access if you want to revisit anything that was going on. Otherwise, feel free to just respond to that Zoom reminder with any questions you have, and we can help get those answered. And a big thank you to Scott and Clint for leading the session today. It was great.
Yeah, I definitely want to say thanks to Clint. He helped me understand a lot of different stuff in SemGrep land and work through all of our demo stuff so that it was the least amount of broken it could be, so we could show you guys cool stuff. So thank you, Clint. Thank you, Pablo. And thank you, Rebecca, for helping us get this all together and out there for everyone to watch.
Awesome.
Thanks for having me. It was a pleasure.
Thanks, Clint. All right, we'll talk soon. Thanks, everybody, for coming.